All right. So welcome everyone to the B12 Lunch and Learn series. This is a series where B12ers, as well as when we're lucky, just collaborators and people from outside of B12 come and give really interesting talks. Today we're guaranteed to have a really interesting talk. There's a kind of an interesting story behind this, like us getting introduced to David and to Nick. Basically, Pao, one of our software engineers, tech leads, and researchers, was leading a reading group, and we read David and Nick's paper. It was really interesting. We had some follow-up questions, like just around future work as it pertains to B12. We asked David on Twitter. We had a bit of a back and forth, chatted for a while, realized, hey, it would be really great to just hear from the authors themselves, come in and speak with B12. And David and Nick were nice enough to come in and share all of their knowledge with us. I'll do a quick intro to both David and Nick, and then hand it off. So David is a second-year PhD student at the HCI Institute at Carnegie Mellon. He works with his advisor, Nick, and he's kind of interested in the intersection of two different things. So basically humans and machines collaborating to co-design things. And specifically, he's really interested in how machine learning can help bolster creativity, something that I know another one of our researchers, Pao, is really interested in as well. And he's interested in how to do something very hard, which is to have technology augment the design process. And so we're really lucky to have David. Nick is his advisor at CMU. Nick is an assistant professor at CMU's Human-Computer Interaction Institute. And it's cool to see Nick's background because he formerly studied and did research in mechanical engineering. Turned that into a bunch of work in things like mechatronics, human-robot interaction, and is now collaborating on all sorts of work around creativity and human-computer interaction more broadly. And he has really nice research experience both in industry, in labs like Accenture's labs, as well as at CMU. One of the things, there are some people in the audience who went through grad school, and there are some people who didn't go through grad school. And one of the things I want to call out in particular about this paper is that this paper was published recently. And papers that were published recently that have researchers, first authors in particular, who are second-year grad students, are very rare. I remember in my first year at grad school, I got to work on someone else's paper and got to contribute to it. And one of the formative memories is sitting in my advisor's office and asking a ton of questions and working on it while we were working on the final draft. And because of the pandemic, I'm assuming that that's not one of the benefits that David had jumping into this research. And so you should be really impressed by the work that David and Nick are doing, because one, it was done by a first author who was in his first year in grad school, and two, it was done, I imagine, very close to entirely remotely. And so research stands on its own. It got accepted to a peer-reviewed conference, and so that's the reason why we're excited about the content. But it's always nice to understand some of the background and the dynamics of the work that went into it. And so this paper is near and dear to B12's heart. At our core, the very first thing we rolled out at B12 was a human and machine powered website design product. We've rolled out a bunch of products since then, all of them kind of around our mission of helping people do more meaningful work. And with every new product that we release, we always ask ourselves this question of how machines might be able to augment the really creative and really analytical work that our experts do. And so it's really great to be able to kind of go back to our roots and see some really amazing, directly applicable research that after learning about it in the reading group, we got so excited, and we're so lucky to have David and Nick here. I want to thank everyone for joining. In a particular shout out, we opened up this talk not just to B12ers, but also to experts, design experts and other experts in the community, and a few of them have chosen to join today. So it's a really cool audience. Really excited to hear from David and Nick. We ask that if you have a question that's like clarifying on a specific slide where things just don't make sense, then you can interrupt, but otherwise, for the most part, hold your comments until the end. Nick is really gracious. He's going to take a look at the chats, and so if you want to ask a question, you can send it by chat, or you can just save the really tough question until the end. And with that, David, take it away.
Thank you so much, Adam, for the introduction, and thank you everyone for coming. I'll share my screen. Right, so I'll begin the talk. So hello everyone, and my name is David, and today I'm excited to talk about our work on learning personal style from few examples, which is recently published in the ACM Designing Interactive Systems Conference. And this work was advised by my advisor, Nick Martelaro, and supported by a gift from Accenture Technology Labs. So the designer needs to understand the client's personal style. For example, some clients may prefer playful or vibrant designs, but others may prefer more hardcore heavy metal designs. So designers often gain a sense of this personal style based on examples from the client. However, especially for newer junior designers, recognizing a common pattern among many intertwining variables such as color, texture, layout, and then synthesizing them into a composite style preference can be challenging. So in this paper, we ask, can we learn a computational model of personal style from only a few examples? So we frame the task of modeling the client's personal style from a few examples as a metric learning problem. In other words, given arbitrary test design we want to evaluate, our objective is to determine its similarity with a set of representative examples selected by the client. So this allows us to then classify the test design between two classes: the client likes or the client dislikes. So our resulting computational model predicts a match score, which is how well the test design matches the client's liking. So in this presentation, I'll briefly go over our three main contributions. We first distill a set of principles for computationally learning personal style. We then manifest the principles in PseudoClient, a deep metric learning framework for personal graphic design style. Our experimental results show that PseudoClient can outperform several alternative methods and can also be adjusted for different designer needs. And then finally, we discussed how PseudoClient can be used as a building block for multiple practical design applications. So we ground the design of PseudoClient in four central principles, synthesized from prior work in design, recommender systems, and cognitive psychology. Learn by example. So considering that the design vocabulary, such as playful or elegant, is inherently subjective and highly dependent and interpreted based on the individual's knowledge and experiences, we do not ask clients to indicate their preferences through such vocabulary, nor do we attempt to fit their preferences into such vocabulary. Instead, inspired by the mood board technique, we simply ask the client to supply us with visual examples and then learn to judge the client's personal style based on them. Learn by handful. So since our task is to learn personal style, Our examples come directly from the client of interest. However, asking the client to select massive amounts of examples is tedious. Therefore, rather than being data hungry, so clients should be capable of working with only a handful of examples. Learn by juxtaposition. Hardwork and recommender systems suggest that it is easier for clients to select positive and negative samples than to judge likability on a spectrum. So therefore, we ask the client to provide us with some examples they like and some examples they dislike. Finally, learn by multiple comparisons. Studies in the learning sciences and cognitive psychology have observed that through repeatedly doing pairwise comparisons, one can quickly learn a common underlying structure of a pool of examples. And we build on this insight in pseudoclient's design. Based on the principles, we designed pseudoclient, our computational model for learning personal style. Pseudoclient takes in a test design and outputs a final match score between 0 and 1, which estimates how well the test design aligns with the client's personal style. Pseudoclient consists of 3 levels of components. The comparison framework, which contains the juxtaposition network, which further contains the embedding network. I'll now briefly summarize each of the components. For further details, please read our paper or visit our project page, which is linked at the end of the talk. The comparison framework takes in test graphic design we want to evaluate and a small pool of graphic design examples the client likes. We then perform pairwise comparisons between the test design and each reference design in the pool to compute their respective match scores. Our final match score is the median of all the pairwise match scores. And a high final match score implies that the test design matches the client's personal style and vice versa. Individual match scores are computed by the juxtaposition network, which takes in a test design and a reference design and outputs a match score based on the design's distances in the learned embedding space. A design's learned embedding space is computed by the embedding network, which takes in a design and outputs its feature embedding. Again, for further details, please read our paper or visit our project page linked at the end of the talk. We performed several experiments to evaluate pseudoclient's performance. We first trained 5 personalized models for 5 people. Each personalized model was trained with only 5 positive and negative design examples. We compared the pseudoclient against 2 common baselines, color histogram distance and a standard convolutional neural network. And we can see that pseudoclient outperforms them. Pseudoclient's performance also improves as we increase the number of design examples available for referencing. By giving different ratios of like and dislike the design examples, designers can focus on optimizing true positive accuracies or true negative accuracies. For example, a designer can focus on optimizing true negative accuracies to really avoid producing a design that the client dislikes. Given 5 examples from the client, we demonstrate searching from a database of graphic designs from dribble.com for the top 10 designs with the highest match scores. Let's also take a look at a quick live demo. So I put together a personalized model that is trained on these sort of dark, grungy feeling graphic designs. And let's look at our test set, which is not trained on. And let's try using this image on our trained personal model. So we get a pretty high match between the test design and our personal model. And you can also see the individual match scores for each of the reference images in the support set, which are all decently high. However, there are failure cases to pseudo-client. So let's look at one example. So I trained a model that tries to distinguish font, and more specifically sans serif fonts or serif fonts. So here are some serif fonts. So not really confident on whether it's a match or not. Oh, by the way, the test image I'm using is this one. So this is sort of like a serif font design. So ideally, it should have a pretty high max score. But when we look at the individual max scores, it's kind of all over the place. So the reason behind this is probably because we downsample the images so much, such that the fonts are really distorted, and yeah, like the really minor details of serif fonts and sans serif fonts are not really captured when we downsample them. Cool. So maybe a potential future work will be to train using like a vector format so that images are not distorted when downsampling. So to wrap up, we suggest potential applications of pseudo-client for augmenting designers. A natural application of pseudo-client is an example-based, style-based search engine. Unlike existing search tools built into many design sharing websites, a search engine built on top of pseudo-client does not require the designs to be manually tagged with keywords. Pseudo-client can also provide rapid automatic design feedback to the designer for evaluating how well the designer's design draft aligns with the client's personal style. Finally, pseudo-client can also be used as a key component in generative design methods, where pseudo-client can guide the rapid exploration of multiple design alternatives. In summary, our paper explores how we can computationally model personal style based on only a few examples. We offer a set of principles for computationally learning personal style. Based on these principles, we designed pseudo-client, a deep metric learning framework for learning personal graphic design style. Pseudo-client can be used as a building block to support the development of future design applications. To find out more, I invite you to read our paper or visit our project page. Thank you for your attention, and with that, I'm happy to take questions.
All right, let's first give David and Nick a round of applause for the amazing work that they did and presented and shared with us. So unmute.
It's funny, it just mutes everybody that I've never actually seen that before, where it mutes everyone because they all clap.
Yeah, it's amazing.
Awesome. It looks like there are some questions here in the chat, and maybe if folks, I guess Daniel and Adam, if you want to ask, I mean, we've got them here, but maybe if you want to ask also, just so for the recording, it's like the question stated on the recording, that would be nice, probably.
I won the race to the chat, so I guess I can ask my question first. Awesome talk there. That was really informative. Appreciate it. I already enjoyed reading the paper, and it was nice to see the ideas spelled out so clearly. My question was around negative examples. When you talk through how the comparison framework works, you mentioned that it compares a sample image to images that the client really liked, and then computes a similarity score. I was curious if the model, or whether you tried experimentally working with negative examples as well to see, if it's similar to images the client doesn't like, maybe that makes it could also decrease the similarity of the match. Did you play with that, and did you learn anything about how positive or negative examples compare in terms of how much information the model can learn from them?
Yeah. For the model, there is two phases. One is the training phase and one is the inference phase. For the training phase, it's using both positive and negative examples. So it's training like in a contrastive manner. So like training to distinguish between positive and or negative examples. So there are both positive and negative together for training. And what you were saying, so in the inference phase, we only look at the positive examples. So like we see how similar they are for the compared to the positive examples. And yeah, it would be cool to also see negative examples. So we did try to play around with negative examples, and we found that sometimes the negative examples are pretty all over the place. So like someone may like some specific style, but they may dislike a lot of other styles. So it might be harder to have a consistency in that sense.
Yeah, maybe to add on a little bit there, that what David said about like picking. So when we had some people try and put together these sets, yeah, oftentimes they could sort of say, yeah, I'm really liking this. And what was interesting was they could sort of, they even through a few images would start like us as people could kind of look and go, yeah, those all like fit together. But yeah, with the negatives, they're like, well, I don't like this, say, grungy work, but I also don't like this like 3D, you know, kind of realistic work or something like that. And again, I'm giving language. That was like one of the things. It's like actually giving language to this stuff is really hard. But because both of those were in there, it did make that negative set more spread out. But one thing that we could imagine doing is maybe thinking if people, when they give their negative set, potentially doing a little bit more, but also kind of grouping a little on their own, such that, you know, they've given a little like, oh, these are probably like this kind of negative and then this negative. You could imagine training, say, a couple different models, comparisons, and doing multiple ones. The other thing, actually, as you were talking, that I thought of that could be interesting is to actually look at the comparison scores with the negatives and see how far away they are. And actually, David, I don't know if we've tried that, because right, we've looked at, yeah, how close are we to the what people like, but actually maybe there's an element of, well, also just trying to get a certain distance away from the things that we don't like. And that could be really interesting to look at as well.
That's really interesting, like a dislike score, like a not match score.
Yeah.
Yeah, there's probably an element to like especially if you're using it in the applications you were mentioning, like a use case being as like mentorship or feedback for like junior designers. You could imagine it's important to teach a junior designer to not design something that's really going to piss off the client. So maybe the dissimilarity score is like has very practical applications too. Thanks.
Yeah, the next one, just I really appreciated how accessible you made this talk. And one of the things that popped up for me when I was looking at the results section specifically was, wow, you really did a lot better than a bunch of the baselines. And one of them that, you know, it's like I'm not a machine learningist, but you see like a CNN, you're like, yeah, that makes sense. Like you'd expect a convolutional neural net to do pretty well at classifying images. And then you see pseudo-client doing so much better. And I was wondering if you could dive like one level deeper and just give some of the insights on how your architecture or some of the design or modeling decisions that you made that allowed you to perform better than something like a CNN along the way.
Yep. So I guess the benefit of pseudo-client architecture is that it is better for cases where there are only a few examples. So CNNs maybe need a lot of data, and they can perform well if there is a lot of data. But then pseudo-client builds on a lot of work in the machine learning community on metric learning or few-shot learning, which is like just using only little data. And so pseudo-client is based on like a lot of few-shot learning techniques, and it's better. Like it works with just 5 positive and 5 negative examples.
Yeah, I think one of the things there as we did some explorations was, as you as you increase the number of examples that you give, the kind of gap between the CNN and the pseudoclient sort of metric learning approach starts to close. But then we're also thinking on like the user end of things, which is actually sitting and picking. We did, and I should say, we didn't do like full on studies of like how many pictures can people pick and like what's comfortable. But we did have a few people try it, and we tried it ourselves a couple times. And even when I was doing it, it was like 20 was about the limit where you were like, yeah, I can kind of sit here and do about 20 of them. And then, but actually to do some of our things, because we actually trained up to, I think at one point like 50 and picking 50 images, you start to lose it actually. You actually almost start to lose what it is that the essence that you're trying to capture. And it just gets quite tedious, right? Picking basically 50 and 50, 100 images is really time consuming. And so from the perspective of like, how would you engage with, say, a client or a user out there, like putting together, 5 can be done in relatively short time, and it can be done pretty quickly because you kind of can skim. And so one of the ways that we did it was we actually had people skim dribble, and you can kind of like see that and look around and stuff, and then be like that, and that's pretty fast. But yeah, it really does start to break down. But yeah, so a lot of it has to just do with the work from the metric learning community. And that was one of the big focuses here was, how do we get closer to few shot learning as opposed to just, okay, how much data can we give it? Because we are thinking of like, all right, what is someone actually going to do when they're clicking and choosing images?
That was really helpful. And then the other thing I really appreciated about when you were presenting the results, you just showed where it performed really nicely and then where there were some breakdowns. And it was really cool to see both sides of it. I'm curious if there's any thematic elements, like where is the model to make it up entirely? Like, is the model really good at determining aesthetics, but it's not so good at determining when like the content is supposed to be different or something like that, that you can help summarize a little bit where the model performs really well and where it starts to run into issues?
I guess the model is available at doing more like a holistic sense of the design. So like, is this design holistically like a grungy feeling or not? But it's not really good at really fine-grained details. So like the serif for sans serif fonts, simply because we downsample the images so much in order to train more efficiently. And another thing that it can't do is, as you said, content-wise. So like, I can't really understand like metaphors. So like, I don't know, like, I can't think of one on top of my head, but there are like some human intuition into like understanding really clever graphic designs of metaphors being used that it can't really done because it doesn't have that knowledge of like human understanding.
Yeah, one of the things that we did try, and actually you may have seen it, David, you might want to pull the, I think it's like slide 3 or 4, the activation map. We tried to take a look at the activation maps of basically what is the network paying attention to when it's looking at the images and seeing, where it's sort of honing in on. Ultimately, we ended up like, we kind of looked at a bunch of them. We were sort of like, we're not entirely sure what it's really focusing on. I mean, so in this case here, right, you have this sort of, I don't know, it might be very small, but you can kind of see that the likes examples are kind of these, got a thin line logos with maybe some text at the bottom, kind of a little maybe Art Nouveau styling in there. And so it does seem to like, it clearly focuses in on the elements of the graphics, and it's not really focusing much on, say, the fact that there's all this white space. But why it's sort of, I guess if you consider those purple hot spots as like, oh, it's really focusing here, like why is it in the middle? I don't know. This is where a lot of like, I mean, there are some techniques in explainable AI for neural networks and for vision systems, but a lot of them are still like actually not as parsable by like a human, and why like what we want to give as a rationale for things. One of the things that we have thought about, and and actually we talk about this in the paper, is this like notion of how much sort of structure could we use and break down on, because we know something about graphic design, we know something about layout, we know something about type. And so in theory, we could actually pull out components like finding the typeface and maybe even using a classifier to recognize exactly what typeface it is, or to at least classify it as serif, sans serif, slab, calligraphy. But then also pulling out, say, high level like structure of like, here's the layout of the page. Like this is where white space is being used. This is where the foreground is. And, but we were sort of, there's always this tension, and David and I went back and forth on this. There's always this tension of like, feature engineering do you do? And how much do you sort of like let the systems learn on their own? And in a lot of cases, we've had so many examples where like, doing too much feature engineering like doesn't seem to work. However, in this case, there might be something where breaking it down with some principles of graphic design could be very helpful for certain elements. And then from there, then saying, okay, now we'll just do kind of end-to-end, pixels from that to the to classification. But yeah, I don't know. I think there's more to explore there, and there's a lot that we could do in thinking about kind of more like foundational principles of graphic design, and then how to blend these kind of two ways of thinking about it.
Thank you.
I think also there was another question.
Yeah, I had a question. So basically, reading from the paper, like noticing you used like 6 classes for pre-training the model. And so one of the questions, like we recently tried to use a similar kind of approach to train on like different business categories. And so we were wondering, like, do you have any insights on how the classes used in the pre-training impact models performance? And if you had any guidance on how should we select these classes and the number of classes for pre-training, like, is there a minimum number of classes that we should go with, like, or is the maximum number, like as we increase the number of classes, would it impact the like performance in any way?
I'll answer this question. So, pre-training wise, I guess. So for pre-training, we're mainly looking at we're trying to let the model learn some really fundamental aspects of graphic design, like edges or like lines or shapes, like just really basic things. Because we then retrain it again on top of that to fine tune it for personal style. So for pre-training, personally, I think it would be nice to have different varieties. So like having some graphic designs with lots of line work and some that have like bold shapes and just like different elements so that the model can have a basic understanding of different types of features, and that'll make it easier to fine tune later on. I also about the number of classes. So I did try training with a huge number of classes, and as we increase the number of classes, it converges less well. So yeah, probably not having too many classes, otherwise the precision will decrease and the quality of the pre-trained model will be not so good.
Yeah, this was something that we had played around with, and like ultimately sort of David, if I remember correctly, it was 6 categories, right? Or 5 or 6 that we ultimately ended up with that seemed to just, the model would converge. Because again, the interesting thing about what we were doing here was pre-training it to take advantage of this weird quirk with visual like deep neural networks, that they learn sort of the simple features earlier on in the network, and we can sort of throw away the later layers, like all the specific classes. And actually that was something when the reviewers were like, wait, why did you do this? And like we had to kind of explain it. And I think actually with the reviewers' comments, we actually ended up explaining it better. But yeah, basically we're taking advantage of this like quirk. And so I don't actually know of other work, where this has been used in, say, like different kinds of modeling techniques. So I'm not sure in your case, like if it was a vision network, And like, I think for vision networks, it seems to work pretty well. Like you can use Inception, which is trained on a bunch of zillion things. And then if you want to come in and I think, you know, one of the examples in a lot of the like intro to ML, like deep learning courses is like retrain it on satellite photography. And like many of the images don't look like satellite photography. The fact that it's learned, you know, some color, shape, edges, you know, contrasted stuff, it sort of has, it can kind of figure that out. The question there is, of course, how far back do you have to retrain? So, right, these things are, you know, these bigger networks and stuff. And actually, David, how far back do we retrain? Because, you know, there are different techniques of this. Sometimes people will just use, like, say you retrain the last layer or the last couple of layers. And sometimes you can actually kind of tune all the layers. If not mistaken, we kind of tune all the layers, right?
Yep.
Yeah. So I don't know, I'm curious, like, and by all means, I realize that this is like your business and things, but it'd be interesting to hear, like, what was the problem that you were training on? Like, what were you trying to classify? Was it something else?
Yeah, it was a vision problem. We were trying to see so instead of using like graphic designs, we were using basically images. And we're trying to figure out if that particular images belongs to a certain business category or not. And so so I think you captured it right. It's a vision problem instead of just a like graphic design problem where we have to worry about style, like edges. In vision, we probably want to think a little bit more about content as well. For example, like a football field definitely looks different from a baseball field. So whereas both of them would have a lot of green color. So that's something, there are some of the things we need to think about. So, but while we were trying to look into it, we were wondering like, how do we classify images? Like how granular should we go with classifications? And like how many classes do we need for pre-training? We tried to do it with the main, like with 2, but I was wondering, and that's why but your guidance was like super helpful.
It's really interesting that like for your case, it needs to have more like a content understanding as well, like understanding baseball via soccer field. I wonder if there's like a multimodal approach. So like having there's this color information, but there's also like there's text information. So like this image has is classified as a baseball field, and that itself is a feature. And then there's also the pure pixels itself. And both of these channels are used to predict things.
Yeah, multimodal would definitely, that's one of the things we are thinking about. Like we could definitely like multimodal approach could help definitely.
Yeah, I think one of the things there is like, what are the different sort of modalities? And if text or language is one, I think it depends on how concrete the language you're using is. So like that was one of the things with this work was design language. The way that we talk about things can often be really ambiguous or very like personalized because people are, you know, you're trying to form an idea in your head and then giving it. I mean, one example that we thought was fun was we were speaking with a web designer and they had said, yeah, in their early days, like they remember a client coming in and saying, you know, what I want this to be is like Technicolor David Bowie on the moon. And it's like, all right, and like, that's the style, we want. And of course, everyone probably is imagining something because, you know, you're pulling an image, which is quite cool. That's the amazing thing that humans do is that's going to spark a bunch of things and you'll come up with stuff. However, though, like just that description alone doesn't actually give you a sense. And that is where, for example, you know, the mood boarding. And so I'd be curious to know like what kind of language from a business perspective, right? You know, when people talk about the business, like, or if you're thinking about a site design, right? I mean, and we even the simple words like, oh, we want this to be like a cleanest, you know, clean, right? Well, okay, what's clean, you know, or we want this to be modern versus we want this to be, you know, or especially people come in oftentimes with like brand values. Like that's another thing designers will work with. And, you know, one thing that you could imagine is potentially pairing up, say, the language that that brands, companies are coming in with, and then asking for some examples like, well, hey, what do you feel matches that? Actually, David, you were talking a little bit, we were speaking with Aditya and Pao earlier, some of the things about, there's this OpenAI's clip that's very interesting because it's a language to image transformer. So I don't know, David, do you want to talk a little bit about some of the things you've been thinking about there?
Oh, yeah. So there's this cool model called Clip from OpenAI, who also made GPT-3. And the thing about Clip is that it is really good at connecting two domains together, namely text and images. So you give the model an image, it can do sort of like a zoomification on like a label for it. Or if you give it some text, it can also like sort of imagine what the image form will look like. So it's also pretty cool because it's trained by OpenAI, who has loads of GPUs and loads of time and funding to train over the internet scale. So they have this like model that is learned on the internet. So it has really great understanding of lots of human knowledge, like concepts, content-wise specifically. I was wondering, just throwing it out there, and maybe it may be relevant to some of the cowork at B12. And I'm also personally playing around with Clip to work more on like video editing things. So like you can sort of know what the video content is about, and then you can sort of play around with that.
Yeah, one of the things that we're also just like looking into and thinking about sort of future work is also like how can this stuff actually be used like with an actual designer or as an interface between a designer and a client, and like what are sort of the interfaces that you provide. So in this case, right, this one was really about sort of the computational model there, but there could be a lot to be done even in just the conversation that's facilitated by some interactive interface that is between a designer, this system, and a client. So of course, like, but there are mood board software like Pinterest, and you can use Miro and things like that. But there's sort of this interesting thing that happens when you ask a client, oh, can you work on this and maybe put together like a small mood board, and then you have a small conversation about it. And one of the things that we're actually looking forward to potentially doing is like maybe if you build like more of an interactive front end, not just the Jupyter notebook, like what does that do, and how does that change the interaction between the designer, the client, and then the AI? And actually, does that change the way we use the kind of computational tools? And so that's kind of an interesting there, because you could imagine kind of pulling up new language or solidifying language. And one of the interesting things that could happen is that by injecting, interestingly enough, by just injecting some form of sort of computational intelligence, you actually can help start to structure the conversations that are important but for a designer and a client. And that of course, for the designer, it could be really quite helpful, or at least that's what we think. And so it's interesting. I don't know, one of the things we're really looking forward to looking at in the future is really like trying this out with people and seeing like, yeah, I don't know, how does this work? I mean, there are of course other elements of like making things super performant and all these things. But yeah, I don't know, just the way it changes the conversation between people is something that we haven't fully explored, but it could be really interesting.
I think that would be very interesting, and it gets to this one other set of questions that I have around like how we might apply this at B12. So to give some context, one of the key questions, we have this 1 hour kickoff screen share where our customer success team, a launch specialist, will speak with our customer, the client. And one of the key questions they ask in a visual way, they're sharing their screen is, hey, let's look at some of the themes that we have and just tell me which of these themes that you like. another key question that we ask is, hey, what are some inspiration websites? What are some competitors? What do you like and not like about them? And qualitatively, what we find is, that the customer can definitely tell us, thumbs up, thumbs down, I like this, I don't like that. But there's so much nuance in the why. And so I'm curious, I believe in your hypothesis, Nick and David, around like the machine helping mediate the conversation a little bit. I think one of the questions I have is when we talk about multiple modalities, like what could the why question look like, or the say more question look like, and could the machine add some constraints to the conversation? So, hey, that you like this inspiration website. Why do you like it? What I'm noticing is that the color palette is very similar to this other inspiration website. And that to borrow Nick's term, this looks like a more traditional aesthetic or a more modern aesthetic. And so it can start to propose some of those, but I'm curious even how you would think about, regardless of like whether it's natural language, whether it's like constrained inputs, like how you might think about like moving to a world where it's not just examples, but also examples with some justification along the way.
I actually, I can take a little bit of that. It's interesting that you bring up the idea of like asking a why question or simply asking a question. There is some work that I was doing back at Accenture actually, and that now still kind of continuing it, but it's moving slowly, which was around how to utilize computational systems to generate designerly questions. So the idea being like the kinds of questions a designer asks. And actually there is research done by a former professor. His name is Oscar Aris. He was my advisor in undergrad. He wrote his entire thesis on the kinds of questions that designers ask and what questions seem to actually move design forward, like which ones are good questions effectively. And there's sort of two kinds: generative questions, there's sort of the what ifs, and then deep reasoning, which is like, how do we do this and things like that. And so one of the things that we were looking into, and we were able to build a basic model of, was we actually used OpenAI's GPT-3 to take in some contextual statements like a product description or a design prompt, and then start to generate questions about that. And so one thing we could imagine in this case is like in a conversation between a designer and a client is, one, if they had their brief, like one, just pulling questions out of that, but also and this could be really interesting, I have no idea how we would do this, I have to think about it, is if you have some visual elements, like, okay, we've built up, say, a mood board, we've maybe even done this model, can we use, say, the similarity models and say, oh, hey, you're getting really high scores here. Can you tell me, why do you think that these are interesting, or like why did you like these? And you could imagine asking those and then pulling information from a client, and that could be really useful. And that could be done too in either asynchronous or synchronous ways. One of the things we had talked about this morning was the difference between, say, asynchronous, like, oh, we're gathering information from a client, and they're maybe working through some, you can imagine like an online portal system of like, hey, like get started, and then when you come into that meeting, it's only an hour, but we're really well situated, versus doing it live. Some of the other work that we just started, but we're looking into, it's interesting you talk about this 1 hour meeting, was we're thinking about how would you do something like like designers do, live streaming design and like getting feedback. In this case, we're thinking about feedback from like small communities of people. You can imagine like a bunch of niche customers, but in the same way, like if you're on the call, is there some computational assistance, what's sitting on the side and like sort of either bringing things up or asking questions, or even just supporting, say, the designer, like giving, maybe some kind of information that they can build on, what is helpful like in real time, versus of course saying, okay, I'm going to talk and then I'll go back and I'll think. The live stream aspect of it is sort of this weird idea that we're thinking about, but it's related to some retail things that some collaborators of ours have been looking into. So yeah, I mean, that's some of the thinking there, is that I do think it's actually possible. I think questions can be a good way to pull information, right? And then just allow people to talk. Potentially having something that supports you. I think designers can be very good at generating good questions, but also imagining sort of computational systems that can do that, could allow either scaling of that process, or even just support, just that it asks something that's even different from, say, what the one designer in the room might think. You know, one of the ideas that we did have was, could you even train something to ask questions that like your team would like to know, like, and I don't know, so you get sample questions there. But yeah, that's maybe one thing in that space that we've been thinking of.
This is great, and you know, if other folks have questions, they should definitely jump in. There's a little bit more time left. But while anyone thinks about final questions, the other kind of, oh, how might we apply it to B12 question I have is this work is really amazing in looking at image data and coming to some kind of like similarity metric around it. And in our case, we're looking at websites, and that's, you know, there's nice structural elements and there's not so nice structural elements to that. I'm curious how you would think about, you know, taking the inputs that we have and turning them into the inputs that this model takes, and what implications that might have to some of the work that you've done.
Think about it. Yeah, like websites are really interesting because they are dynamic and they are more than one screenshot mostly. So there's the work by Benchista Kumar on website guys that looks at both. So they look at both structural data, like the tree structure, and also the color space. So I guess maybe like landing pages are suitable. So like, or like under construction pages, like pages with just like one page, like a really big header, or like a really important first impression. Those ones are more suited for the model because that first impression is really important.
Yeah, I think one of the things here was, and we had actually talked about this, not in the sense of websites, but like that, because we're thinking, I mean, and it makes a ton of sense, right? Like the actual thing we probably want to be able to do is like web design, like full, which is very complicated. And we're sort of, oh, we're going to start small because we're trying to figure out like, wait, how could we do this? One of the next steps that we were thinking about was slide layout. And one of the interesting things there is that you do have some elements of a structured representation underneath it, but also sort of a visual, although it's still like, you know, it's not as nearly as complex. The other thing there too, and this is probably one of the big differences, is there is of course the visual style, which is what we're sort of able to kind of model computationally now, with the interactive style or feel of a site, which is a whole different, you know, a whole different arena. And I'm not sure, like that in my head would take more like thinking and probably more tools to figure out like, okay, how do you model how like the flow of a site feels, or how you would navigate that? Because a lot of web design is about kind of figuring that out. And then it's those things that is the interaction you're looking to achieve that actually drives a lot of the visual style. Whereas in our case, you know, it's sort of like, oh, you can imagine logo design maybe fits more with that because it's more, am I representing sort of an idea? And slides are sort of in the middle because they're not as interactive per se, but you are thinking about, say, how you read information across a set of slides and things like that. Yeah, so I think there's some element of trying to understand, one would structure of it, but secondly, I don't know, and I think it's how you actually encode the interactions and the flow through a site, and that's something that isn't always well documented in, say, the code. It's not inherent to the code, for example, but we do represent it in ways. So, for example, like in Figma, you have your flows, and actually, if you do full-on prototyping in, say, Figma or Framer or whatever, like you actually know where things can go, and so there can be a structured thing there of like what the paths are. Actually, that's a neat idea. I don't know if could you do something like that? And then you could imagine modeling like similarity of flow types. That could be kind of interesting.
I saw like there's this work on there's this data set called the RICO data set, which is like mobile interactions, like where do people click, like what button do people click on the mobile UI, and then what's the next screen, and then what button they click on that screen, and what's that next screen, and they have this like flow of that mobile thing.
Yeah, there's some limitations with RICO, right? What I don't remember, is it that they're all image, or is it they're all? I feel like I remember we read a paper, and there was someone else who made it, I think, another thing. I might be misrepresenting it, but either way, I remember something about this. But yeah, you're right.
Well, as you can tell, there's lots of future directions to go in with a lot of this work, and I think some of this discussion at the end is a big part of the reason why we're so grateful that you made the time to come in and share this work with us. One of the things that Nick and David have been really gracious about is also with their time. They're around if anyone is interested in having a follow-up conversation with them. Obviously, it's all digital. We can schedule some of those conversations even asynchronously. It doesn't even have to be today. So if some of the questions that came up or some of the ideas that have come up have like sparked some thoughts in your head, just reach out and I'm happy to connect whoever has the questions and ideas with David and Nick. And I hope that just given how much overlap there is here, we're able to collaborate on some work in the future. So now I'll ask everyone to unmute and thank David for an amazing talk and Nick for some amazing thoughts and additional ideas. And so everyone please unmute and give David and Nick a round of applause. Thank you guys.
Silent clapping.
Yeah.
I'm trying to clap quietly to avoid the auto muting.
Yeah, but thank you all.
Thank you, everyone.
Yeah, this was great. Thank you so much. And we're looking forward to all the future explorations.
Cool.